Before we start developing our own Pol smart contract, let's talk about the basics of Solidity, so you have some basic understanding what syntax look like, what options we have, and so on. But I will cover the fundamentals part. It's also important to know that smart contract is basically a piece of code. When once it's deployed on the Ethereum blockchain, it's immutable, meaning you cannot change it. So if you made some bug or if you didn't implement some function, then it's a kind of a problem because we cannot update it, or at least update it so easily depending how the contract was implemented. So it's not changeable. Just think of that. Once you deploy it, it's not changeable. That's the easy way to think about the smart contract. Every smart contract starts with something called pragma solidity and then the version of Solidity which we are using. So let's say this one will be 0.6.6. This tells the compiler that we are using the version of Solidity 0.6.6. We can also use the head sign saying that we will use the version of Solidity of 0.6.6, but also the another version changes on the last number, meaning it would either use 7 or 8 and so on. You can see what versions are available inside if you go to Solidity compiler, and you can choose different versions, and you can also see the version numbers. Currently 0.66 is the newest one, so I'm going to use that one. Every contract starts with the keyword contract and the name of the contract. Let's call this one test. And everything we write inside. You can imagine this as being a class or the object or some wrapper where we are going to define functions, different objects, variables, and so on. Let's start with the primitives. So, like in any other programming language, we have numbers. Here they are called unsigned integers. And always when we are choosing unsigned integer, we need to choose the size, such as uint 256. uint 16 and so on. So let's just pick uint 256 and let's call it my number. But one thing before we move on, let's just go to settings and change the theme because I see it's not highlighting properly. It's not good for you to learn like this. So let's choose settings and let's change the theme from dark to light. Now we can see it's actually highlighting the types and also other keywords. So I think let's stick with this theme for the rest. After numbers, we also have booleans, which are called bool. Let's pick random, like is active. Then we have bytes. Also, when we are choosing bytes, we need to choose the number. You will also get auto completion. Let's call it password. And then, of course, we have strings, such as let's call it name. Whenever possible, I suggest using bytes instead of strings, as it's taking much less space, and later on when I will explain about the gas, it will cost much less to interact with our contract. Next, we also have arrays here. So for example, if you want string array, we can just write string, array, and names, or we can use bytes 32 array, bool array, and so on. Then we have something a bit different, which is called the mapping. Mappings are, you can think of them like a hash map, like instant lookups. We can have a mapping of uint 256 to boolean. So this is our type and we need to give it a name. Let's call it IDs. So what this does, you can think about it as a hash map, as I mentioned. So each ID from 0 to max of uint 256 will have the mapping something like this: 0, true, 1, false, 2, true, and so on. But two things with the mappings. All of the mappings are initialized. If it is boolean, then all of them will be initially to false. So that means the mappings from 0, maximum of integer 256, would be initially to false. So that means it will create this hash map by default. I will get back to mapping after I introduce new type, which is called, it's special one and only in Solidity. It's called address. Let's call it AD. So address is special type. Every person on Ethereum blockchain has this address, or every wallet has an address which looks something like this, and they are unique. So if we want to store the ID of this person, then we could create a variable called ID of type address, because you cannot assign this to string. So we could even have a mapping of uints to addresses, which means initially all of them would be initialized to something like this. So always remember the mapping, even though you didn't initialize it, initially it will always have values, and then later on you can change them and modify them, but initially they will always have values. And then of course we can also group all these primitives, arrays, mappings and so on in what's called object, and in Solidity we call it a struct. This is similar to C language where we also called objects structs. So let's call this object person. And this person, as I mentioned, could have ID, which would be of type address. It could have a name of type string. It could have age of type, well, age is not going to be so big, so we can write even 24. And then we can work with this object. So with the mappings, we can even have mapping of the address to the actual struct, something like this. So each address, let's have it, would be mapped to a person, which would be initially a struct of that person ID, which would be empty string, name, which would be empty string, and then also age, which would be 0. So it would create these mappings by default. Address to the struct of person. We can even insert another struct inside struct, so we can nest them, such as, let's say we would have object called home, that would be our struct, and the home would be name of the variable. So if we would have another struct called home, and inside we would have address, house number and so on, we can define them here and then just pass it inside the struct of this person. We could even have a mapping here. So basically in the struct you can use all the types. So just to recap, the primitives are very similar to another programming languages: uint, boolean, byte, string, arrays such as string arrays, boolean arrays, uint arrays and so on. Then the special one, which is called mapping. You can create different types of mapping. We have address to person, or we can have uint to boolean, or whatever you like. This is a special type. And then we have another special type, which is called address, which is a string of 42 characters, but it's special type of string. And then we have structs, which are objects which group multiple variables. Inside structs we can have another struct. So let's delete these things. And we can also have enums with the keyword enum. Let's call it the day, and let's give it some values such as Monday, Tuesday, and that's our enum called day with those values, because for enum we need to initialize values in the beginning ourselves. And last but not least, we can have a type called event, but this one will make sense when I show you to it in the context, so I'm not going to show it now, but just so you are aware.